Hello everyone and welcome to another Java Basics video on the ToborTech YouTube channel. This video today is about the concept of encapsulation, which is very important in object-oriented programming. Without further ado, let's get started. Today's object-oriented programming topic is encapsulation, which is also known as data hiding. In short, what this is encapsulation means restricting the access of certain data to only the class it is located in. So if you recall from the previous video of this course, we talked about modifiers in Java programming. We talked about the access modifiers, public and private. So to accomplish the encapsulation of an instance attribute, we need to declare it to be a private variable so it can only be accessed directly from within the same class. So here I have two classes. The first one is going to be the person class. So this person class has three instance attributes which are now all declared to be private. And the values of these instance attributes will be set to the inputs passed into the constructor when we create new person objects. In the main class, which is our driver code, which is where our person class is being used, in the main method, we have a person called P being created, which is a new person passing in the values of Joe, student, and an age of 10. Now here, if I try to print out p.name, we'll actually see that we'll get an error because name was declared to be private, therefore we cannot access this instance attribute's value from outside of the person class. We can only access it from within the person class. And that's a very important distinction that we'll need to make clear in this lesson. So if I paste this program in an online Java editor, we'll see that we indeed get an error because name has private access in person, which means that we cannot access it from the class main. Now our data, which are the instance attributes, are all hidden from the rest of the world using the private modifier. But what if we want to access and modify these private instance attributes because some data are necessary for the functioning of the rest of the program? Well, a private instance attribute cannot be accessed from a different class directly using dot notation. Like this, we can't write the object dot name, where name is a private instance attribute. What we can do is we can use a public method to return that value from within the same class. Because the method is going to be public, the method we can access from outside of its class. So here I have, again, the person class. We can see three new methods are added. They're all public. We have a public getName method, which returns a string, which is this.name. So even though private, we see the private modifier modifying the string instance attribute name here, we can still access this value from within the same class. So we have this method in the class person, which returns the instance attribute name. Same thing with job, we access it using the getJob instance method, which returns this.job, and then for our int age here, we return this.age in this integer returning method getAge. So in our main class, in our main method, we have a person P again, the same thing as before, and here instead of writing p.name, we write p.getName. So now we're using public getter methods to get the values of our instance attributes. So normally we cannot directly access the values of private instance attributes, but we can use public getter methods to get the values because the getter methods can access the private instance attributes since they're in the same class. So let's take a look at the output of this program. And we see Joe, student, and 10 printed out because we're using the public getter methods now and there is no issue with using that. Now we can't modify private instance attributes outside of their class either, so similar to how we use getters to access private instance attributes, we can create public setter methods to set the values of our private variables. So here we have the person class, same thing. We have the getters right here, and we have three setter methods here. They all return void because we don't want it to return anything in this case. And we have set name, which takes one parameter, a string called name. And here what we write is this.name, so we're accessing the private instance attribute name. This is this.name is equal to name. This name is right here. And here we have set job, which takes a parameter job. It's assigned to the instance attribute this.job, which is right here. And we have public void set age, which takes an integer parameter age and sets this.age to that value. So here we can create our person once again, p.setJob intern. So we pass in a value to our setJob method. So job is equal to intern, and we in turn set this.job to be intern. And here we have a print statement printing out p.getJob, which should return our new value of intern. So let us run this program. And we see intern printed out rather than the student, which is what we initially defined the job to be. So practice setting your instance attributes private and using getters and setters to access and modify the values of these attributes. This is really open-ended. You can feel free to create any class you would like and just practice using encapsulation by hiding the data from the outside world but allowing data access through public getters and setters. Now let's move on to some benefits of encapsulation. So it may appear right now that with our simple example programs above, that getters and setters are just simply solutions to encapsulation, which is a challenge that we create for ourselves in the first place. It seems as though it is not necessary. And while it may appear that encapsulation is utterly useless right now, it actually has plenty of benefits like data protection, it can make our code more readable, and more. It's also a very good and common practice. It's actually a convention to hide some data within classes that should not be accessed or modified from the outside. And let's just take a more practical advantage that encapsulation has, which is restricting data modification. So for example, in our person class, the instance attribute age should always be non-negative because you can't have a negative age. So we can make sure of that in the set age setter method so that we cannot set age to be a negative number, which we cannot do if we directly modify it using dot notation, if this is public. So here we have our private instance attribute age, and here we have our getter for our age instance attribute, and here is our setter for it. It takes the same thing, it takes an int called age, but instead of directly setting this.age to be age, we check, is age greater than or equal to 0? Which is checking, is this a valid age? If it is, we will set this.age to be equal to age. Otherwise, so if the user has somehow decided to change the age of an individual to a negative number, we'll say invalid age must be non-negative, and age will not be modified. So here we have the main method, where we set the age first to 100, that's perfectly fine, and then we print out the age, we should print out 100, and then p.setAge -8. Because it does not pass our check right here, Java will say, hey, this is not valid, so we will print out invalid age must be non-negative, and p.getAge will still give us 100. Let's take a look if this is true by running this program. So we see 100 invalid age and 100 once again. So this is just one of the examples of a benefit that getters and setters and encapsulation offers over using directly accessing public instance attributes. So if we have had a public int age, then the user can just modify the age instance attribute without going through this check process, and we can eventually possibly change a value to a non-valid value. Congratulations, you have learned about encapsulation, one of the 4 fundamental concepts in object-oriented programming. And there you have it, encapsulation in Java programming. If you learned something in this video, please consider subscribing to our channel down below. If you have any questions, feel free to leave them in the comment section. And with that said, thank you for watching this video, and we hope to see you in more tutorials.